Hey Kodiaks, I've got several chemical reactions that I'm going to run for you today. The idea being that you notice the reactants before and the products after, and that you're able to balance chemical equations now. So the first one we're going to do is number 1 on your worksheet, which is taking hydrochloric acid and zinc and putting them together. So in this round bottom flask you can see is hydrochloric acid. Looks like water, definitely not water. On the paper towel here is zinc metal. I can zoom in on that a little bit for you, and you'll notice it's shiny and silvery, and it's a little bit soft as far as metals go. In order to do this reaction, I'm going to put the zinc metal inside of a balloon, because one of the products of this reaction is hydrogen gas, and I don't want to just let the hydrogen gas go. I want to collect that hydrogen gas in the balloon so that I can add a flame to the hydrogen gas. We'll have our own little mini Hindenburg, but that'll also be one of the reactions that you'll be observing. Will be the hydrogen gas igniting in the presence of the oxygen in the room and making water vapor. So I wish you were here to do this with me, because it's kind of fun, but alas. Keep social distancing, wearing your masks, and not going out in large groups, and maybe, just maybe, we'll have in-person school again. So here goes reaction 1, and what I'm going to do is put the balloon over the top of the round bottom flask and drop the zinc in, and then the balloon should catch our hydrogen gas as it forms. So ever so slowly, as the reaction starts to go down there, this balloon will, I'll pan up here just a little bit, that balloon will fill with hydrogen gas, and it's getting there, but it's going to take a little while to do that. But observation-wise, I'll go ahead and zoom in on this reaction for you so you can take a look at what's going on. There, you can see that we have bubbles forming. You might even be able to, here, if I can focus that just a little bit, and may have to reshoot this if I didn't quite use enough hydrochloric acid to make a nice big balloon. But if I zoom out, you can see that the balloon is catching hydrogen gas and slowly inflating. I'd like for it to inflate a little faster and a little more than this, but this will work. And we still have a fair amount of zinc in there reacting, so it'll be producing gas. And what we'll do is we'll end up coming back to this reaction later, but that's the first reaction on the sheet. And the balloon, we'll let the balloon get as big as it can. We'll collect as much hydrogen as we can. One thing that you've noticed that you can't see or feel or perceive through the camera is that the base of this is getting warm. So one of the clues that you may have a chemical reaction on your hands is that you will observe a change in temperature. And of course another clue is that we started with a solid metal and a liquid, and from that we're getting a gas. So we're definitely getting new stuff. And you can see that the balloon is getting quite a bit bigger now. So moving on to the next reaction, we're going to skip reaction 2 and move on to the next reaction, which is the combustion of isopropanol or isopropyl alcohol. The IUPAC name for isopropanol is, or what you guys would call rubbing alcohol. The name is 2-propanol because the OH group, the hydroxide group, is on the second carbon of the 3 carbons that are in it. And so I wouldn't suggest that you do this at home, but this lab bench is made of a material that is relatively flame resistant, and 2-propanol burns at a relatively low temperature, so it's not going to damage the table. I'm going to turn out the lights though. And that way you'll be able to see the combustion just a little bit better. And there you go. So this is the combustion of 2-propanol. Notice that you had a clear liquid reactant, and then right now what's being produced, of course, is some heat. There's a flame. There's definitely something going on as the 2-propanol combines with the oxygen in the air in a combustion reaction to produce carbon dioxide and water. So that's probably long enough on that one. We'll blow that one out. And I'll turn the lights back on so you can see. And we'll move on to reaction 4 on your handout. Reaction 4 on your handout is going to be sodium carbonate, Na2CO3, and it's an aqueous solution. So I've got it right here. I'm going to pour it into the test tube. So there we go. And then into that test tube, I'm going to add, this is sodium carbonate in the test tube now. I'm going to add calcium nitrate to that. And when I add the calcium nitrate to it, you'll immediately see that those 2 clear liquids, right here is the calcium nitrate by itself in the beaker, it's just a clear liquid, but calcium nitrate and sodium carbonate together make this white solid that eventually will settle out into that test tube. But it looks as if you've made milk, but of course you didn't make milk. That would be silly. But you could. Well, actually you couldn't. But there is the reaction. Solid white substance from 2 clear liquids. That one is a double replacement reaction, by the way. So next up, we'll have a decomposition reaction. And the decomposition reaction is going to be reaction number 5. It's the decomposition of hydrogen peroxide. And for this I'm using 28% hydrogen peroxide, which is much, much stronger than the stuff you would buy at the grocery store. And also, to get it to decompose rapidly, I have a solution of potassium iodide, and then I mix that with some food coloring and some dish soap so that when the oxygen gas bubbles get produced by the rapid decomposition of the peroxide, you'll be able to see it in the form of like a foam, a bunch of foamy bubbles. So I'm going to pour the hydrogen peroxide so that you can look at it. The hydrogen peroxide is also just a very clear liquid. I'm going to pour that in there, and we will see, hopefully, what happens. And here it goes. Maybe. Should get some relatively rapid decomposition of this peroxide, and I may need to add just a little bit more of a catalyst to it in order to get it to go a little bit faster, because that's not very dramatic at all. So I'm going to throw a little bit of a catalyst in there. This is manganese dioxide. Now we might be cooking with gas once that reaction gets going. And what you can see is because I put the soap bubbles in there, it's not quite as dramatic as I would like, but the reaction is definitely happening. And you can see that all of that hydrogen peroxide is getting rapidly converted, not as rapidly as I would like, but rapidly converted to oxygen gas bubbles. And you can see the bubbles a little more readily because of the soap that I put in there. So now it's, if I pan up, you'll be able to see that there's just this like foam being produced, and that's the oxygen bubbles from the hydrogen peroxide decomposing. And you can also see that our hydrogen balloon has gotten a fair bit bigger, which is nice. It should make a good explosion. Explosions are, controlled explosions that is, are kind of fun. So back to the decomposition of hydrogen peroxide. If I zoom in on it, you can see that it is over the top of the flask that it's in, and it's running over the top and making a large mess, which is why I have it in a